In this video, I will show you how to balance an oxidation-reduction reaction. So, balancing redox reactions. Well, to balance a redox reaction, you cannot just use the method you use to balance a normal equation. It requires a special method. And the method that I'm going to teach you is called the half reaction method. So let's do it on another page. So half reaction. I'm first going to tell you the steps on how to do it, and then I'll show you with an example. The first thing you have to know about this is that it will vary depending on if you're on a base or an acid. So at the beginning of the problem, it should tell you that something like balance this in acidic or in an acid solution or in a basic solution. This is acidic. So be careful on what it says in the problem, because these have to the basic solution has more steps than the acidic solution. So let's start with the steps you have to use for both. So the first thing you will always want to do is find the oxidation numbers of each element. This will tell you if it's which compounds undergo oxidation and which compounds undergo reduction. This is essential because you will have to do different procedures if it's to the compound that is getting oxidized and the compound that is getting reduced. So separate. You want to separate it into an oxidation or reduction reaction. You will understand what is an oxidation reduction or an oxidation or a reduction reaction when I do the example. Now the third step is a little more complicated. You want to add electrons to each of the separate reactions. So you will separate it into an oxidation reaction and a reduction reaction. So add electrons, and I'll write as 3.A. So for if oxidation, I shouldn't say if, because there's always oxidation occurring, on oxidation reaction, you'll want to add electrons to the products, to the product side. And then 3.B, on reduction, you will want to add electrons to reactant side. To the reactant side. So now let's go to step number 4. You will have to add water to balance the hydrogens. Add H2O to balance hydrogens. I'm sorry, I gotta help myself. It's to balance the oxygens. To balance oxygens. So let's say if you have 2 oxygens on one side and 1 oxygen on the other one. So you will add 1 molecule of water. Because it only has 1 oxygen, then you have 2 here and 2 here. There's 1 oxygen. So you add water to balance oxygen. Then, this is what I said, I confused myself. The 5th step would be adding hydrogen to balance hydrogen. but you'll be adding a hydrogen ion, not like just a hydrogen by itself. Just you'll want to put, like, if you have, let's say, water molecule here, you'll want to put 2H plus. So you'll have 2 here and 2 here. And now we get into the base part. If you have a base, you'll want to have a sixth step. You'll want to add the hydroxide ion. So you'll add hydroxide to each side that had a hydrogen ion added. So add hydroxide to each side with hydrogen ion. So if you added two hydrogen ions to the product side, you'll want to add 2 hydroxide ions in the reactant side and 2 in the product side. And when you do this, this will combine and form water. But you'll see that in the practice problem. So to summarize it, let me write it. If in acidic, you will want to go from step 1 to step 5. If in basic, you want to go from step 1 to step 6. Oh man, there would be a step 7, but that's just like simplifying. So you could figure that out. Now let's get to the problem. So I'll be doing a problem in basic solution just because if you do the basic solution, it'll cover the acidic solution and the basic solution at the same time. Because to do something in base, you have to do it in acids first, and just add the hydroxides. So it says balance the following process in basic solution. So we have that's horrible. We have MnO4 minus, this is aqueous, plus Cn minus, this is aqueous too. Now what that forms is MnO2 which is solid, plus OCN minus, which is aqueous. So let's go back to our steps. So the first thing we have to do is find the oxidation number of each of the elements. So let's go back to our problem. Let's start with this. We will call the manganese X, and we know that we have 4 oxygens, and its oxygen number is -2, and it's an ion, so it will have a -1 here because of this minus. So we get that x is equal to x minus 8 is equal to -1. So x is equal to +7. Then let's do our other, like the other one, this one. So this case x, we have 2 oxygens, where an oxidation number of -2, and it's on an ion, so it has a charge of 0. Then we get that x is equal to +4. So the manganese went from +7 to +4. Now so just by knowing this, we know that the manganese, or the permanganate ion, is getting reduced. So the Cn minus will be getting oxidized, just because one has to get reduced and the one has to get oxidized. So we don't really have to find the oxidation number of that one. So the first step is done. Now let's go back to the steps. We found which one gets oxidized and which one gets reduced. So now we have to separate each into a different equation or a different reaction. And that's why it's called the half reaction method. So let's erase this. See? Now we want to separate the the compound that is getting reduced from the compound that is getting oxidized. So we know that the permanganate ion is getting reduced, so we'll put that in an equation, and the Cn minus is getting oxidized, so we'll put that in another equation. You want to leave some space, then write an arrow, and the permanganate is getting reduced into MnO2, right? And this one OCN minus. Now, the third step said that we have to add each electron depending on which is getting oxidized and which is getting reduced. So you have to add electrons in each side, and because manganese is going from +7 to +4, and it's a reduction reaction, the electrons are added on the reactant side. So you need 3 electrons, right? From 7 to 4, you need 3 electrons. The carbon, I forgot to say that, is going from +2 to +4. You can determine that because N is a constant, it's -3. So you can figure out the oxidation number. But carbon, cyanide is getting oxidized. So you'll add electrons on the product side, and when it's going from 2 to 4, you simply add 2 electrons. So step 3 is done. Now let's erase this part. And then our following step is adding water to balance the oxygens. So in the permanganate reaction, we have 4 oxygens here and 2 oxygens here. So we add 2 waters, and then we have 4 on each side. That one's balanced. Now in the cyanide one, we have 0 in the reactant side and 1 on the product side, so you only add 1 water, so plus H2O. And that is step 4. That's done. Now you want to add hydrogens to balance the you want to add hydrogen ions to balance the hydrogens. It doesn't really fit here, so let me write it better. So that looks better. Now we want to add hydrogen ions to balance the hydrogens. We have 4 hydrogens in the product side in this equation, so we'll add 4 hydrogen ions, and that is balanced. Now we have in this equation we have one molecule of water, so that's 2 hydrogens on the reactant side, so we simply add 2 hydrogen ions. That makes it balanced. Now, one more thing. You will want to balance the charge, like the charge on both equations. So we have 2 electrons here and 3 electrons here. So we want to make them both a number that can cancel out when you add both equations. So we'll multiply all of this by 3 and all of this by 2. So 3 times 2, 6. 2 times 3, 6. And then we will have, let me go to another page. Actually, I could just write it here. So you want to add both of them up. So just try and write really small. And you multiply this by 2, so we'll have 2 plus 6 plus 8. And to not waste your time, I'll just pause it and write it. So that is what you get. And now you just want to cancel stuff out. This goes with this. This goes with this and leaves 2. And this goes with this and leaves 1. So let me write it nice now. But there's one more step, because this is in basic solution. You want to add a hydroxide ion per hydrogen ion you added. So we have 2 hydrogen ions here, so you simply write OH, 2 OH minus and 2 OH minus here. And this gets combined with this to form 2H2O. So I'll just write the result. And now this cancels with this, leaving only 1. And this is our result. That is how you balance redox reactions.